Hey guys, we've been talking about weathering. Weathering is where rocks break down at Earth's surface. So far, we've talked about physical weathering. Physical weathering is where rocks just simply crumble without a change in the chemical composition. Today, we're going to look at chemical weathering. Chemical weathering is where chemicals actually break down the rock through chemical reactions, and it changes the composition of the rock. One example of chemical weathering is what we call oxidation. And we're very familiar with oxidation here in Rochester, as our cars often experience rust. This rusting or oxidation is a result of metallic elements, metals, coming in contact with oxygen. And then the actual metal chemically breaks down and changes composition. Rocks do the same thing. We have mafic rocks. These are rocks that are rich in iron. When these rocks are exposed into the atmosphere, when they reach Earth's surface, oxygen reacts with it to chemically break down the rocks. Carbonation is another type of chemical weathering. You guys may recall calcite is a mineral that when we placed a weak acid on it, bubbled and dissolved, releasing carbon dioxide. Calcite is found in limestone rock. Limestone rock dissolves from weak acids falling with rainwater. When rainwater mixes with carbon dioxide in the atmosphere, it forms a carbonic acid. And when the precipitation falls on these rocks, it dissolves it. Entire cave systems are hollowed out through the dissolution of limestone and calcite. It actually eats away or chemically dissolves the rock layer. Here's a landscape that experiences carbonation. It's limestone rock. Notice there's cracks and fissures in the rock. So when rainwater falls on the landscape, it moves down through the rock. Now, since it's acidic, it starts to eat away at the rock or dissolve the rock and chemically break it down. When the rainwater drops down and the water levels recede, what's left behind are hollowed out caverns. You may notice that there's these little sort of teeth-like features that hang from the ceiling and are on the ground of the cavern or cave. These are what we call stalactites and stalagmites. They're a lot like icicles, but we could call them sort of rocksicles. As that carbonic acid eats away at the limestone, the dripping cavern will contain calcite or calcium carbonate. As it drips, the calcium carbonate hardens and solidifies and turns into these really interesting features in the cavern. After the water recedes and is removed from these caverns, sometimes their structural integrity, their strength, is undermined. It's a lot like pulling out the frosting from an Oreo cookie, where then the cookie would simply collapse. We call these sinkholes. Sinkholes are locations where the Earth's crust collapses because of the hollowed out nature of the crust. Due to the dissolution of limestone, the underlying rock is removed and the top portions cave in. Humans could actually further chemical weathering at Earth's surface by creating all sorts of pollution. When we burn coal, it releases compounds of sulfur dioxide, and that sulfur dioxide mixes with rainwater to form sulfuric acid. Sulfuric acid, when it falls with rain, is called acid rain. This rain has such a low pH value that it can dissolve statues. Statues are often made of marble. Marble is a metamorphic version of limestone, if you guys remember, which contains calcite, and therefore it dissolves very easily. So here we have an ancient statue that has chemically dissolved from the acid rain, and it lost all of its features. Finally, the last type of chemical weathering is what we call hydrolysis. Hydro is a prefix for water. Lysis is actually a word that represents the deterioration or breakdown. So this is where water breaks down rocks. Feldspar is a mineral often found in granites, and granites form deep within the earth. When they're exposed to the atmosphere, however, they become very unstable when water reacts with them in a hydrolysis reaction. It transforms and changes the composition from feldspar into clay, and then the rock simply crumbles and breaks down chemically. That's it for today, guys. We'll see you next time.